Imagine walking through the wilderness. Miles of pristine forest stretches before you. Towering peaks, hidden valleys, quiet lakes, and trout-filled rivers, all there for you to discover. At a time like this, you can't help but admire the early explorers, those daring scouts and trackers who first found their way through the wild with little to guide them but the sun, the moon, the wind, a winding stream, or some faraway mountain ridge. Now, here you are today, ready to blaze your own trails. But unlike the explorers of old, you'll be using skills learned in just a few short hours, the skills of map and compass reading. Welcome to Finding Your Way in the Wild, an introduction to using a compass and map. In this video, we'll show you map and compass use in a variety of situations with a variety of people and terrain, from deep woods to high mountains. It's the ability to use a map and compass that will allow you to leave the well-trodden trail and strike out on your own. And you'll do it with confidence, trusting your map and compass skills to get you home safely. For the fisherman, this means finding your way to a secluded lake or river, or plotting exactly where you caught that big one. For the hunter, mastering map and compass skills means finding those hard-to-reach places filled with waterfowl, or maybe trailing that big buck and knowing exactly where you are at all times. And for everyone, it means a chance to explore more of nature, finding that out-of-the-way campsite, distant waterfall, abandoned mine, or Indian ruin. In this video, you'll learn 3 important lessons: how to read topographical maps and plot courses with them, how to use a compass and follow a bearing to your desired destination, and finally, you'll learn how to use a little common sense along with your map and compass for complete confidence in the wild. Now, let's get started. Topographic maps. Here's what the Earth looks like from an airplane. We see rivers, roads, buildings, hills, forests, fields, everything that makes up the landscape. This view is what a topographic map represents: an aerial or vertical photograph of the Earth's surface, backed up by ground surveys. So let's take a detailed look at a topographic map and see what it tells us about the geographical lay of the land. Like all topographic maps, it gives us 5 categories of information, the 5 Ds of map reading: descriptions, details, directions, distances, and designations. First, let's look at descriptions. At the top of the map, you'll find its name. A map is usually named after a town, a lake, a mountain, or some other major feature of the area. The map's name also appears at the bottom of the map, along with its number. You'll need this information for ordering a map. The names in parentheses at the edges and corners of the map are the names of maps that border this one. Longitude hatch marks and numbers run across the top and bottom of the map. Connect them and you have meridians that connect the north and south poles. Latitude hatch marks and numbers run along the right and left side of the map. Connect them and you have parallels, running parallel to the equator. So remember, longitude lines run north and south. Latitude lines run east and west. The final piece of description information are the dates at the bottom of the map. They indicate when the aerial photo was taken, when the ground survey was done, and what year the map was printed. For instance, on this map, the aerial photo was taken in 1975. The ground survey was completed in 1976, and the edition was released in 1978. The dates are important, since, as we all know, nothing stays the same. Old barns fall down, rivers dry up, and rustic dirt roads turn into superhighways. So keep in mind that maps are only completely accurate for a few years. Be prepared to make additions. Our second category of information is details. All the landmarks we see from the air are represented by various symbols on the map. So when you're walking along in the wilderness, you know exactly what's around you by looking at your topographic map. Where are the rivers located? The lakes, the mountains, the roads. Each landmark is represented by a symbol. The four major categories of symbols are color-coded black, blue, green, or brown. Man-made or cultural features are black. They include roads, trails, bridges, churches, cemeteries, railroads, dams, and schools. However, major highways are sometimes printed in red. Water features are blue. They include rivers and streams, lakes and ponds, swamps and marshes, water wells, and oceans. Vegetation features are the color green. Forests, orchards, and scrub fall into this category. However, only more recent maps use green as an indication color. So when ordering maps, specify woodland copy. White areas represent cleared or cultivated ground. The fourth category of symbols represents the biggest difference between topographic maps and ordinary road maps. Topographic maps indicate the shape of the land and elevation changes. These changes in land forms and elevation are represented by thin brown lines called contour lines. You'll notice that every fifth line is darker. This fifth line is an index contour line. Notice the numbers next to the index lines. These numbers indicate that every point along the index line is that elevation above sea level. The distance in height between the contour lines is known as the contour interval. When the lines are further apart, the terrain is relatively flat. If they're closer together, the grade is steeper. And if contour lines run together, it's a cliff. On maps with relatively level elevation, these contour intervals could be as little as 5 feet. On maps with mountainous regions, each interval could represent 50 feet. The reason is simple. There just wouldn't be room enough on the map for smaller intervals. To find the contour interval of your map, look along the bottom margin. On our map, the contour interval is 10 feet. It's important when you're in the wild to relate elevations around you to contour lines on your map. This is what a hilltop looks like: a cliff, a valley, a draw. Try testing yourself. Pause your VCR, take a pencil and paper, and write down the letters A through F in one column. Then match the corresponding number of each contour line configuration with the silhouette letter. We'll show you the right answers at the end of our discussion on maps. Now, pause your VCR and give it a try. Our third category of map information is directions. With a topographic map, you always know what's north, south, east, or west of you by simply holding the map so the words are right side up. If they are, up's north, down south, left is west, and right is east. If you have any doubts about the direction of a map, look for this declination diagram in the bottom margin. The line marked true or geological north points directly north. Also, you can mark the top of the map in red for north so you don't forget. Distances is our fourth category of information. Like all maps, topographic maps are drawn to scale. That means one small unit of measurement on the map represents larger units on actual land. For instance, 1 inch on the map equals 2 miles of actual distance. The most common scales used for topographic maps are 1 to 250,000, 1 to 62,500, and 1 to 24,000. If we choose the inch as our measuring unit, the scale of 1 inch to 250,000 inches is almost exactly 1 inch to 4 miles. The scale of 1 inch to 62,500 inches is almost exactly 1 inch to 1 mile. And the scale of 1 inch on the map to 24,000 inches in the field becomes 1 inch equals 2,000 feet. Obviously, a scale of 1 unit to 250,000 units would cover a great deal more territory than a scale of 1 unit to 24,000 units. Since the distance you cover on foot is relatively small, it's more accurate to use maps with a scale of 1 to 24,000. They cover smaller areas. Notice how much larger the detail looks? That makes them a lot easier to read. Maps of this scale generally cover areas from 49 to 68 square miles. Since the features appearing on a 1 to 24,000 scale map are large, the map is referred to as a large-scale map. A 1 to 62,000 scale map is also considered a large-scale map. However, a 1 to 250,000 scale map, where the features appear small, is called a small-scale map. Once again, if you look in the bottom margin of the map, you'll find the information you need. These scales help you measure distance on the map. They're given 4 ways. At the top, distances are given as a fraction, 1 to 24,000. Remember, 1 inch equals 24,000 inches, or 2,000 feet. Below the fraction, distances are given in rulers that we call bar scales. They appear in fractions of miles and miles, as feet, and as kilometers and fractions of kilometers. With these scales, measuring distances is easy. Simply measure the distance between 2 points and compare it to the bar scale. If you don't have a ruler, mark off the distance between 2 points on a piece of paper. Then measure the distance between the 2 marks on the bar scales. Our distance here is 7/10 of a mile. When measuring distance on a road, keep turning the paper while making small tick marks along the road's center line on the paper, and then measure the whole line on the bar scale. Practice measuring distances. After a while, you should be able to estimate distances on a map just by looking at them. The 5th and final category of information a topographic map gives you is designations. Notice the variety of typefaces used for names on this map. A variety of typefaces makes it easier to distinguish between the different features. Names of places, boundary lines, and area names are printed in an upright Roman typeface. Water features are printed in slanting italics type. Elevation features in public works use block letters. Special descriptive notes use slanting block letters. That's it. Now you know the 5 Ds of topographic map information. Now it's time to take our map into the wilderness and go for a walk. Our map tells us there's this nice little spot just off this path. We know by practicing our distance estimating that it's about 1.5 miles from where we're standing. So, which direction should we head? The easiest way to figure out which direction to go is to orient the map. By that, we mean simply holding the map in front of you and turning it until features on the map line up with the landscape in front of you. Look for features like mountain ridges. Learning to read contour lines and recognizing symbols accurately really comes in handy here. Other good landmarks are rivers, lakes, roads, or buildings. Here we see that the mountain ridge on the map fits the one we're facing. Now, all we have to do is head west on this path to our left for 1.5 miles, and we'll find what we're looking for. Remember to keep the map oriented with the terrain so that everything lines up as you walk along. Here's a handy hint for knowing how far you've walked. Count your double steps. That means count each time you put down your left foot. 1, 2, 3, 4. For the average person, 1 double step is roughly 5 feet. 1,000 double steps is roughly 1 mile. If counting double steps seems troublesome, try timing yourself. These times will vary depending upon your pace. Also, your pace length will vary when you're walking uphill or downhill. Try timing yourself at a comfortable pace for a distance you know to be exactly 1 mile. Then use that time as your gauge for measuring miles. As with all things, practice makes perfect, so practice taking walks with your map. Learn the different symbols for landmarks like rivers, lakes, buildings, and roads. Know what a cliff or valley or plateau looks like with contour lines. Practice measuring and judging distances. Practice can be enjoyable. Make an outdoor experience of it. Try taking your map to a high point of land with good visibility of a number of landmarks. Look out over the landscape and see if you can pick out the different landmarks on your map. Learning to recognize landmarks will help you know where you are at all times, and that will help you feel more safe and confident in the wild. The only thing left to know about maps now is, where do you get them? Topographical maps of the United States are prepared by the U.S. Geological Survey of the Department of the Interior. They're referred to as USGS maps. Obviously, there are hundreds of maps to choose from. So your first step is to order a topographic map index circular for the states you're interested in. Write to National Cartographic Information Center, 507 National Center, Reston, Virginia, 22092. The index is free. This index divides each state into quadrangles, so you can order a map for a specific area of any state. Remember, specify a woodland copy. That way, you're sure to get a map with the vegetation features marked in green. A good place to look for maps is at your local outdoor camping store. They're also good places to get first-hand information about local areas of interest. For areas countrywide, write to U.S. Geological Survey, Distribution Center, Box 25286, Denver Federal Center, Denver, Colorado, 80225. In Canada, topographic maps are prepared by the Surveys and Mapping Branch of the Department of Mines and Technical Surveys. Write to Map Distribution Office, Department of Energy, Mines and Resources, 615 Booth Street, Ottawa, Ontario, Canada, K1A OE9. Before we move on to compass reading, let's take a look at the answers to the contour test you worked on earlier. Pause your VCR and check your answers. The compass. Today's precision compass is a strip of magnetized steel balanced on a pivot, free to swing in any direction. That direction is, of course, north. That's because the Earth acts like a giant magnet, with the North and South poles as its ends. Compasses come in a variety of designs, from fancy and expensive to simple and inexpensive. The compass we'll be working with is a typical model that's specifically designed to work with maps. It consists of three main parts: a magnetic needle, a revolving compass housing, and a transparent base. The magnetic needle is suspended on a sapphire bearing on which it swings freely. The north end is painted red for easy identification. The compass housing dial is marked with the initials of the four cardinal points: north, south, east, and west. Each space between the hatch marks represents 2 degrees. Every 20 degrees is marked with numbers from 20 to 340 degrees. The transparent dial also has an arrow called the orienting arrow. It indicates north or 360 degrees. You align the red magnetic needle with the north orienting arrow. The lines running parallel to the orienting arrow are orienting lines. The transparent base plate is designed for using on a map. An inch ruler often runs along one edge, a map scale along another. A direction of travel arrow is also engraved in the base plate. It tells you which direction to walk. Field bearing. Let's learn how to use all the features of a compass by taking a field bearing. The three-step procedure is foolproof. Step 1, pick out a landmark. Hold the compass level at waist height. Point the direction of travel arrow straight ahead toward the landmark. Step 2, without moving the base plate, turn the dial until the red magnetic needle lies directly over the orienting arrow. It will be pointing north. Step 3, read the bearing on the dial at the index hatch mark. Our landmark lies at 150 degrees. Let's try one more object. Step 1. Hold the compass at waist level. Point the direction of travel arrow directly away from you and face the landmark. Step 2. Without moving the base plate, turn the compass dial until the magnetic needle lies directly over the orienting arrow. Step 3. Read the bearing on the rim of the dial at the index hatch mark. The new landmark lies at 320 degrees. Walking a bearing. Here's a simple exercise you can try in your own backyard for walking a bearing. Place a coin or a marker on the ground between your feet. Set your compass for any direction between 0 and 120 degrees. We'll use 80 degrees. Orient the compass so that the red magnetic needle and the orienting arrow align. Pick out a landmark upon which to guide. Now walk in the direction pointed to by the direction of travel arrow for 15 steps. Stop and add 120 degrees to your original bearing. Your bearing is now 200 degrees. Pick out a new landmark. Orient the compass and walk another 15 steps to the 200-degree bearing. Stop again and add another 120 degrees to your bearing. Your bearing is now 320 degrees. Orient the compass and walk 15 steps following the direction of travel arrow and the 320-degree bearing. Now stop and look down. Your marker should be close by. If it's not, try again, being more careful. Hunting with compass. Carrying a compass is a must for hunters. It can get you there and back. Say a friend told you about a great hunting marsh about a mile southwest of this crossroads. But to get there, you'll have to walk through heavy terrain. No problem. Simply turn the dial on your compass to halfway between south and west. The hatch mark and direction of travel arrow should be aligned at 225 degrees. That gives you a southwest bearing. Hold the compass at waist level and point the direction of travel arrow directly away from you. Turn your entire body without moving the compass. Keep turning until the red magnetic needle aligns with the orienting arrow that points north. Look up. You'll be facing southwest. Sight a landmark on your southwest bearing and walk to it. Follow the direction of travel arrow to another distant landmark. Keep walking from landmark to landmark until you reach that great hunting spot. Returning home safely. Getting home is easy because your compass remembers the way home even if you don't. There's no need to change a thing on your compass. Hold the compass at waist level in front of you, but this time point the direction of travel arrow toward your body. Now orient the compass by turning your body until the red magnetic needle and the orienting arrow align. Look up and start walking. You'll be heading 180 degrees from the bearing you followed into the wood, back to the area you started from. Fishing with compass. By using your compass, you can mark the exact spot where you caught that big one. It's simply a matter of using cross bearings. Pick out two prominent and permanent landmarks that are approximately 90 degrees apart. In this case, that point looks like a good one. And how about that bridge? Aim the direction of travel arrow at the point. Now turn the dial until the red magnetic needle aligns with the orienting arrow. And there you have it. The point lies at 160 degrees. Write down the landmark and its bearing. Do the same for the other landmark. Next time you go fishing, just maneuver your boat into position using your two cross bearings. Drop anchor and start catching them. Declination. Before we can learn to use a map and compass together, we need to talk about declination. It's the Earth magnetism that draws the magnetized needle to the north. This does, however, create one small problem. The magnetic North Pole, which attracts the compass needle, is located about 1,400 miles south of the geographic or true North Pole. It's at Bathurst Island in Upper Hudson Bay. That means when you're using a map and compass, you have two north directions to deal with. True north, which a map shows you, and magnetic north, which the compass needle shows. The difference in degrees between these two norths is called declination. In the United States, declination varies from 20 degrees west in Maine to 30 degrees east in Alaska. Remember, the declination diagram for your map is located on the bottom margin. You can allow for declination two ways: by correcting your compass bearing and by marking magnetic north lines on your map. To correct your compass for westerly declination, simply add the number of declination degrees to your compass bearing. For example, if your compass bearing is 40 degrees and your declination is 9 degrees, then your actual bearing is 49 degrees. For an easterly declination, subtract the number of declination degrees. So if our compass bearing is 120 degrees and your declination is 12 degrees, your new bearing is 108 degrees. You can remember this rule by the phrase, east is least, or subtract, and west is best, or add. Why not make your topographic map speak compass language? It's easy. Look at the bottom margin of your map for the declination diagram. Simply continue the magnetic north line up through the map. Now draw parallel lines about 1 to 2 inches apart. Be sure and draw carefully or your bearings could be off a few degrees. By adding these magnetic north lines, you can forget about the declination problem. You're ready to plan a route to whatever destination you like. Map and compass together. Okay, so far we've learned to use a topographic map for understanding the lay of the land and how to use a compass for pointing us in the right direction. Now it's time to use them together, because once you've mastered the skills of compass and map, you'll always be able to find your way in the wild. Using your compass and map together, you can reach any destination safely and easily. To plan a course on your map, first connect your starting point with your destination by using the edge of your compass base. We're at Natoa's Peak, and we want to go to Ptarmigan Tunnel. The direction of travel arrow will be pointing in the same direction. Hold the base of the compass firmly against the map and turn the dial so that the orienting arrow and lines are aligned with the magnetic north lines that you drew on the map. At the index line, read your bearing to your destination. Ours is 140 degrees. Now, orient the compass by turning your body until the red magnetic needle aligns with the orienting arrow. Look up and follow the first landmark. Unfortunately, the best route to your destination is seldom a straight line. But that's where your topographic map reading skills come in handy. By planning carefully, you'll be able to avoid steep grades, marshes, and other obstacles. Simply draw your route on the map using your compass to calculate bearings. By using your compass and map together, you can plan a complete excursion from the comfort of your own kitchen. Overcoming obstacles. Even with the best of planning, you're bound to occasionally run into an obstacle you can't get across. Don't panic. Simply walk around it using right angles. This diagram shows how to do it. Say this mountain ridge was steeper than you anticipated. To get around it, turn at a right angle from your course. Now count your double steps or paces until you clear the obstacle. Next, turn at a right angle back to your original course. Once you have cleared this side of the obstacle, make another right angle turn, this time back toward your original sighting line. Count the same number of steps you took to clear the obstacle on your first right angle turn. Once you reach that spot, make another right angle turn, and you've returned to your original bearing. What to do if you get lost? As in most sports, The secret to a good offense is a good defense. So defend against getting lost by planning carefully. In the wild, it's doubly important to know where you are at all times. That's where your compass and map can help. Before starting out on any excursion, be sure to determine your exact position on the map. Know how far you're going and how long it will take you. Be sure to let someone know where you're going and when you expect to be back. Allow extra time because it almost always takes longer than you think. Follow your compass bearing carefully from landmark to landmark. Check your progress by comparing landmarks around you with those on the topographic map. Select landmarks ahead from the map. Take the time to look behind you occasionally. It'll look more familiar on your way out. If you can't find your destination, don't panic. It doesn't mean you're lost. Stop for a moment and take inventory of the situation. Double-check your original compass-bearing calculations. Did you remember to allow for declination by drawing magnetic north lines on your map? If you did those two things right, chances are your destination is still ahead. Always trust your compass and map. It just may be taking longer than you planned, so push on. If you still can't find your destination, try backtracking to the last known landmark on your route. Simply turn the direction of travel arrow toward your body, orient the compass, and follow the bearing back to the last landmark. If you're still confused, use your map reading skills. Look for prominent landmarks that you can follow, like railroads, rivers, fences, or lake shores. Remember, with your map and compass, you're never really lost. Nature guides. If you should somehow lose your compass and map, let nature guide you. Use some old scout tricks. Check the wind direction. What direction was it blowing when you started? Chances are it's still the same. Some areas have prevailing winds that always let you know your direction. Even if there is no wind, in some areas the prevailing winds are so constant the trees are shaped with the short branches toward the wind. Use the obvious. Watch the sun. Remember, it rises in the east and sets in the west. And if it's night, try and find the North Star. Locate the two pointers. They are the stars at the forward edge of the dipper. 5 1/2 times the distance between them in a straight line up from the dipper will be the North Star. The dipper rotates about it. Helpful hints. Before you strike out to blaze new trails in the wild, here's a few last helpful hints. Get in shape. You'll be surprised how quickly you tire in wilderness terrain, especially if you're carrying a backpack. Jogging or even simple walking can toughen up your legs. Take your backpack along. You'll need to get used to carrying an extra 20 or 30 pounds. Start light and work up. Speaking of walking, did you know that you can walk a lot further if you walk with a constant, steady, unbroken rhythm? Set an easy pace. Roughly speaking, the energy expended in walking doubles with each mile-per-hour increase of speed. So take your time and smell the roses. A 10-minute rest every hour is a good idea too. When walking up a hill, straighten up and shorten your stride. Try carrying a walking stick too. Even on flat ground, it'll give you added stability. And by all means, wear a good pair of hiking boots. Today's boots come in a variety of styles. Regardless of style, what you want is a good fit. A blistered pair of feet can make a long day even longer. Look for a boot that gives you plenty of support. It wouldn't hurt to bring along a little moleskin just in case you do blister. For more detailed information about map and compass, read Be Expert with Map and Compass by Bjorn Shellstrom. And for more information about backpacking and camping, check out these two videos. Backpacking Made Easy, and How to Enjoy Camping from Your Very First Trip. That's about it for our video. The only thing left to say is, Go on, do it. Get out there and enjoy the wilderness, because now you know that with a compass, a map, and a little planning, you've got what it takes for finding your way in the wild.